Hello friends, this is 1 minute. Hello friends, this is Durga from IT University. Those who are joining on YouTube, just for your information, this is just backup for my live students. So in case if we could not answer your questions, bear with us. That being said, we have been discussing about transformations and actions within Spark. And we are in the middle of understanding the concepts of map and reduce. Okay, so let me take you to the material which I'm using it for reference. The course name is Apache, Spark, and Scala. Okay, and then as part of this, we are in the middle of transformations and actions. And we are talking about shuffling and combiner at this time. Okay, so yesterday I have started discussing about it. Unfortunately, the picture which I have drawn yesterday is gone, so we have to draw it again. So we'll spend some time on that. So as someone have suggested, let me draw a rectangle for deck of cards. Okay, and let us assume that these guys are mappers. Okay, and then let's assume that there are two reducers. And in the middle, we have the shuffling phase. Okay, so this is shuffle. So this is deck of cards. Mappers. And reducers. So as I have mentioned to you, I have covered two use cases. Let me draw a few lines here before I get into further details. So this is one chunk, this is another chunk, and this is another chunk. And this chunk will be processed by this mapper. This chunk will be processed by this person. This one will be processed by this person, and this one will be processed by this person. So we have four chunks, and each of the chunk will be processed by one of these guys. And I have spoken about two use cases. One, grouping the data by suite, and the other one, getting the count by suite. Okay, the first one is just a grouping activity. The main difference between the two is the number of input records and the number of output records after data is processed will be same when it comes to the use case of grouping. Whereas when it comes to aggregation, irrespective of number of records in the data that is being processed, the output will be only 4 because there are only 4 suites within a card. So let me make a note of the cards also. Okay, let me change the font size in a moment. So there are 3 attributes. One is sorry. One is color. Other one is suite, and then other one is script. So in a deck of cards, we have only 4 suites, right? So when we try to get count by suite, the output after processing the data will be only 4 records. So when it comes to aggregation, when it comes to grouping, what these mappers will do is, for each of this chunk, each of this mapper will actually divide into 4 different groups. Okay, and let me draw a line here. So as I have already mentioned, there will be 4 suites. One is club, other one is diamond, and then spade, and then heart. Okay. So if we do manually, each individual will actually group this data like this, and then the same thing will happen with the next guy also. So let me select this. Okay. So the same thing happens with this mapper, with this mapper, with this mapper. All these guys are doing is they're just grouping the data. Uh, 1 minute. Let me copy once again. Okay, each one of this guy is actually grouping all the clubs together, all the diamonds together, all the spades together, and all the hearts together. So this guy, as we have two reducers, approximately this reducer will get all the records related to two suites. It could be club and diamond, or it could be club and spade, it could be club and heart, approximately. When you actually implement, it need not be the case because there is an algorithm using which this distribution happens. And when we talk about the algorithm, I will get into details. For now, we just assume that this reducer will get records related to two suites, and this reducer will get records related to two suites. Okay, let's assume that he get all clubs and diamonds, and this guy get all spades and hearts. Okay, so let me do this. So I'm only copying up to here. This guy, let us say, will get all the clubs and diamonds from all the mappers. Similarly, this guy will get all spades and hearts. So if you draw lines, clubs from this mapper, clubs from this mapper, and also this mapper as well as this mapper will go to this one, and diamonds also will go to this guy. Whereas spades, stuck. Okay, I think it is stuck for a moment. I'll be drawing. Yeah. I know that. I actually we figured out the issue. The issue is I am using Mac, and Mac doesn't come with Ethernet port, so I need to use the external device. I think that external device is broken. We just validated today, and we figured out the issue is because of that external device which will connect to the Ethernet port to the USB of the Mac. So I will fix it today, and I will get a new device by tomorrow, and from tomorrow it will be smooth. Okay. So now you see, I think now it is back to normal. So I have a one of my friend sitting beside me who is monitoring this and letting me know immediately. I think it is normal now. So now this reducer will get spades from all the mappers. Okay, and as all the clubs, all the diamonds, all the spades, and all the hearts are grouped together, now the final output will be the random cards are now grouped using suite. Okay, that is one use case. And now if you want to do the count, you don't need to pass the card completely. Okay, and at the same time, you should not group all the clubs, all the diamonds, all the spades, all the hearts together, and just pass those things to the reducer to perform the final count. The side effect of that is each of these reducers have to process at least 500,000 of records if our total data set size is 1 million records, which is not very efficient, especially when it comes to aggregation. For that, there is a concept called combiner. So what this mapper will do is, on top of grouping this data, he also get the intermediate results. He will actually get the count of clubs, count of diamonds, count of spades, and count of hearts. And this mapper will get count of clubs, count of diamonds, count of spades, and count of hearts. So in the best case, hardly these guys have to process 16 records. Um, because we have four yeah, both together have to process 16 records, because this guy get all clubs and all the diamonds with the intermediate result from each of these guys. And finally, this guy have to process only 8 records. This guy have to process only 8 records. If the pre-aggregation is performed by the mapper himself, at least up to the intermediate result. Otherwise, if that aggregation does not happen on the mapper side, the output will only be, the output of the mapper will only be grouped by the key, and then reducer have to perform the aggregation, and performance will be very means performance can be bad. Okay, so so this is when we talk about layman terms, how we can identify the problem and we can solve the problem in the layman terms. Now, if you want to put the technology, okay, as part of mappers, there are 3 APIs. One is map, one is flat map, and other one is filter. And as part of the reducer, there are a bunch of APIs which I have not covered. Okay. So the sorting happens as part of the shuffling phase. When it comes to this intermediate phase is called as shuffling. So in layman terms, when we talk about individuals, mapper actually groups the data, and he will pass on the records, all the clubs he got, to the reducer when it comes to sorting. When it comes to grouping. When it comes to aggregation, this mapper will actually do the intermediate results also, and he will give the intermediate results to the reducers. Whereas when it comes to technology, this is divided into 3 phases. One is map phase, second one is reduce phase, and third one is shuffling phase. So as part of the map phase, we will only apply the transformations at row level. Either we will filter, we will transform one record to another record, or we can we will unpivot the one record into many records. That is the logic which we will perform as part of the code which we develop to satisfy the mapper phase. Okay, and execution will be done by Spark. And now the grouping and all, we don't take care. It is taken care by the Spark execution engine, and that part is called as shuffling. Okay, so the actual partitioning, all the grouping, all the clubs, all the diamonds, all the spades, all the hearts together is done by the shuffling phase. Okay, and then finally aggregations are done using reducers, if we talk about aggregations. Now, if we don't use a concept called combiner, what will happen is, as part of the reducer task, when the data is executed, all the records have to be processed. But if you use the concept of combiner to pre-aggregate at the mapper side itself, the combiner logic will be executed by the shuffling phase. We will not be developing quite extensive code for combiner separately. Okay, we will only tell the logic, and that aggregation will be done as part of the shuffling phase. It does not happen when the mapping happens. You don't write any combiner or reducer logic as part of the mapper. It all happens on the shuffling side. We have to tell what is combiner we are supposed to use. And coming to sorting, unlike in MapReduce, it is not called as shuffling and sorting in Spark. Whereas in Hadoop MapReduce, the intermediate stage is called shuffling and sorting. So data will be grouped by key, and also data will be sorted within the key. Whereas in Spark, they only call it as shuffle. They don't call it as shuffle and sort. So sorting is not guaranteed within the key by the Spark. That's what I understand. I didn't get proper reference where I can confirm whether the data will be sorted or not. But when I ran the programs, data is mostly sorted. But I think sorting is not guaranteed as part of this intermediate stage. Okay. So that's about the combiner. We will see them in action when we actually start looking into the transformations. So we develop primarily two types of functionalities. One is mapping functionality, other one is reducer functionality. So now let us go back and see what are those APIs. Okay. Uh, so you can see here in the index, there is the aggregations, there are joining, and there are set operations. Set operations is a bit different, and also there is sorting and ranking, and also group by key. All these things, group by key, sorting and ranking, aggregate by key, reduce by key, join, co-group, Cartesian, all these APIs will actually result in shuffling when it comes to Spark. Whereas in Hadoop MapReduce, if you are already familiar with the Hadoop MapReduce, this is for you guys. There is only one API called reduce, and you have to implement all the logic. If you have to join the data, you have to implement the join as part of the reducer. If you want to do co-grouping, you have to do it in the reducer. If you want to aggregate the data, you have to do it in reducer. All these operations have to be performed in the reducer itself. Whereas in Spark, there are a bunch of APIs which are provided to you, and you have to use the appropriate API depending upon your requirement. So we'll go into those APIs starting from now. Okay. So first thing is aggregations, and so there are three APIs which can be used to perform aggregations. One is reduceByKey, second one is AggregateByKey, and third one is groupBykey. Even though by using groupBykey you can do the aggregation, you should not use groupBykey to perform the aggregation. The reason is there won't be any pre-aggregation that will be happening on the in the shuffling phase as on mapper side. On the when I say mapper, I'm not talking about code at this time. I'm talking about map task. When the task is being executed, if you use groupBykey, no pre-aggregation will be performed on the map task side. Okay. Even on the reducer side, we have to provide the logic the way we want to aggregate. So let me demonstrate it and show you the side effect of using groupBykey. Okay. So now I'm logging into the lab. Okay, I'm launching Spark Shell. While it is launching, let me make an announcement for the YouTube folks. So those who are on YouTube, if you want to, if you like the training and if you want to be part of future sessions, you can send me an email at training@itversity.com. Training@itversity.com is the email ID. If you need environment to practice, so here I am connecting to the lab. So if you need lab like this, go to labs.itversity.com and enroll for the lab. Okay, the plans are these: for $15 for 31 days, $35 for 93 days, and $55 for 185 days. So whatever I'm covering as part of these videos, you can practice those things, and the content will be free. It will be available for you. If you need any support while learning, you can go to discuss.itversity.com and you can post the questions over here, and we'll try to get back to you as quickly as possible. Okay, and also if you like the content, please click on the like button. That will get me some traction to reach out to more and more people, and it means a lot for us. That being said, now the Spark Shell is launched. So let me run this thing, which I have ran yesterday. Let me see if I already have some code here. I will use the same thing. Yeah, so let me read this from retail DB. And then okay. So if you look into order Okay, let me actually do this. Let me show the data structure and explain what those columns means. Otherwise, it might not make much of sense to you. So if I run first command, we can preview the data. So the first one is order item ID. Second field is order ID, which is foreign key to the order ID in orders table. And then there are few more tables like product ID and I think this is quantity, and this is subtotal, order item subtotal, and finally this is order item price. Okay, so if I want to let's say get the count of order items for each order, it's a very simple use case. I just want to get the count for each I would like to get the revenue for each order. Okay, so this is order ID and this is revenue. So here what I'm trying to do, I'm as part of the map function, we have to create key value pairs if we have to use any ByKey functions or join. Okay, that's why I have started with I have enclosed this as part of the circle brackets because it's a tuple, and this is the key, which is order item order ID, and this is the value, which is revenue for that particular order item. Now if I do order items dot take of 10 for each println and hit enter, you can see the data. So this is the order ID for 2, and there are 3 order items for that order ID, and this is the revenue. Now I want to just aggregate this order item subtotal for each order and get the revenue for each order. That's the use case. Now if I use groupBykey, so it will look like this. I am naming it as order items. GroupBykey equal to order items group by key. Okay, at any point in time, if you want to see the DAG details, you can take the name of the RDD and then you can actually say who debug string. It actually give you the DAG level details. So you should know how to read this. It's in the form of a tree. You have to first go to the lowest level in the tree. So and then in that whatever you just have to go to the leaf level details. So you can see here. First, I read the data from the file and created this map partitions RDD, and then I have used the map. Sorry, I think I have created the Hadoop RDD to begin with. So so there are 2 parts to this. First, I am trying to read from the file, and second, I am applying the map function. So when I actually only do this, you can see it has created the map partitions RDD. Okay. Now, what is that? Okay, it got stuck. So let's wait for a moment. So Piyush is saying he raised a ticket on. Yeah, so I have been saying that yesterday also I told that using Cygwin with Spark Shell is not a showstopper. Okay, you can use DOS prompt and you can move forward. So we will close this ticket Piyush today so that the issue will be closed. Yeah, now it is back. So let me move on. So that is not a showstopper Piyush. You can either use the DOS prompt or if Cygwin works, you can use Cygwin or you can ignore. But once you do SSH, that's what I don't have Windows machine, and I tried searching, but I couldn't get any solution for it. So you can use DOS prompt when you launch Spark Shell on your PC, but when you connect to the lab using Cygwin, it will work. It will work without any issues. As long as you try to run Spark Shell on your PC, it will not work. using Cygwin. But once you do SSH, it will work. So the issue is integration between Cygwin and your local Spark shell. Okay, so you can still log on to the lab and you can launch Spark shell using Cygwin, and I don't think there will be any issues with that. Okay, anyway, let's go back to this. So as part of this one line of code, it has generated three items in the DAG. Okay, first it reads from data from the file, which result in Hadoop RDD, and then it returns a map partitions RDD. And then we have applied the map function. Map function again returns map partitions RDD. So you have to read it in a tree structure. So when you are navigating through the tree, you should not go through the branches. You just pass on. Once you go to the leaf level, you have to read this information from the leaf first, and then you have to come to the branch. So in this case, these two lines of code is primarily for this. These two leaves of the DAG is primarily to read data from the file. And then we have applied the map function. So this is about map function. And then we have applied the groupBykey. So in more complex RDDs, you will get a more complex DAG, and you should be comfortable in understanding that. Okay. Anyway, now groupBykey generates a shuffled RDD. Okay, what does that mean? It will actually group by key as part of the shuffling phase. We haven't provided any logic. And if you look at the output type after group by key, the output type is also a tuple. The first element is of type int, which is order ID. And for each order ID, it will create a iterable, which means a collection. Okay, so it's similar to group by, but group by is generates a map, whereas the group by key generates a tuple. So it is a bit easier to deal with tuples than map. Okay, and also the way it generates the map is you will see the key both in the key as well as value, unless you apply some transformation to discard the key to come up in the value. That is the side effect using map. Whereas here, by using group by key, your key will not be included as part of the iterable. That's why it is iterable of float. Okay. So now we got. Let's preview the data. Order items gbk dot take of 10 dot for each println. You can see for each order ID, it has created a collection, and we have to add these things. So as part of this shuffle phase, already shuffle the RDD is created, and as part of this shuffle phase, it doesn't do any transformation. Okay. So now you can take this order items gbk. So when you use group by key, there will be a follow-up transformation either by using map or flat map, depending upon what you want to do. For each input record, if you want to get one output record from this tuple, you have to use map. For each input record, if you want to get multiple records, you have to use flat map. So in this case, I just want to get the revenue for each record. Hence, I'll be using map. So I'm using map here. Okay, and then I can say rec dot underscore 1 to get the key, and then rec dot underscore 2 is nothing but a collection. We have to convert it into list. So I'm saying rec dot underscore 2 dot to list. So if you recollect the APIs in the list, so let me open another session with respect to Scala. If you say val L equal to 0 to 100 to list, and if you say L dot and hit tab, for getting the sum, we have sum function, which is a Scala API. We can use that because as part of this map, which is a RDD API, we are actually dealing with Scala collection within each record, which is converted to list as part of this map function, and then I can use dot sum to get the sum. Okay, and then let us display the results. Okay, how to use collect. So there is a question here. Yeah, so already the data is divided into key and value pairs. That's why we have to convert into pairs using map function before using any of these ByKey transformations. Otherwise, it will not work. The syntax itself says the input has to be key value pair for groupBykey. So if you go to the documentation, official documentation, so there is another part of your question. You are asking if you want to create a composite key. You just have to make sure that a tuple within a tuple will be your composite key. The tuple can have two elements. Yeah, so Bala have responded to that. Thank you, Bala. Yeah, I think you got it, see. If you still did not get, let me know. Anyway, I have to show the documentation also. So if you go to the transformations here, see, is it clear for you? Yeah, cool. So you can see here, when called on a dataset of KV pairs, so you have to use any of these ByKey transformations on KV pairs only. So we have to use map transformation to convert, to identify the tuple and convert your input record into a tuple so that we can perform any of this ByKey. And to answer Sri's question specifically about having a composite key, either you can create a object as key using both the attributes, or you can create a tuple. As long as it is a valid structure, you are good to go. You need not use only tuple the way Bala have mentioned. You can even use your custom object, which will hold the key details, and you can use that key itself, that itself as key. Okay, but probably when you use custom things, sometimes you might have to provide additional functionality, uh, but most likely it will work. I think as long as you have compare to and equals implemented for your object, you are good to go. And I think those things will come automatically if you use case classes. That's why case classes is very, very important. So that being said, now you got the revenue. Now let me go to the uh, Spark UI and show few details. Okay, I do not remember what is the port number. I have to pick up the port number. Five three two one four. Okay, so let me go and use 53214. Okay, now you see this is the last. Yeah. You will see these programs again. I'm just trying to demonstrate what is the negative impact of using groupBykey when it comes to aggregation. And then when we will actually see the reduceByKey and AggregateByKey, and we'll come back to the groupBykey for a bit more complex use case. So don't worry too much if you don't understand the complete program. The main thing which you need to understand is these things. Okay. It got stuck, so let me wait a moment. Yeah, now it is back. Now if you see, uh, so we are dealing with order items. So you can actually get the order items dot count. What is the number? It is 172,198. And you can see there are multiple levels of tasks. And if you go back, I will come back. I will explain this DAG in quite a bit in detail when we actually talk about execution lifecycle. But for now, I will be focusing on the uh, um, this area, shuffle, read, size, or records. Okay. So if you go back to the jobs And if you click on this latest, not count, if you click on this collect job, which is executed earlier, so it is saying this is skipped because it has already executed earlier and it has the results in the memory. That's why it is saying it is skipped. So as part of the map, it haven't done anything. So we have to go back a bit to the earlier jobs when it has executed for the first time. So let me see. I think it could be this one. Yeah. So this is the location where it actually read the data. Okay. Where the group by key have happened. And you can see the shuffle write is approximately 1 MB and shuffle read is 476 KB for take. Take is a program which we have ran just to see the sample data. So here you can see there is 5.2 MB in data which is passed as input, and it has returned 1 MB as output. The reason for the reduction in the data is our original data set have 7 fields, and uh, uh, we have processed only 2 fields out of that. So the output that is written back into memory is only 1 MB. So shuffle write is only 1 MB. Now if we go back to the latest one where we perform further after doing group by key. Okay, so this is the one. You can see it has read. So here you can see this is the this is the stage which has completed. And the stage 1 is skipped because this processing is already done and it is in memory. Okay, and we have seen that 1 MB is shuffle right as part of the earlier job when it actually read the data and processed the order ID and the order item subtotal. And now it try to read that order item subtotal and order ID, and it try to do the aggregation. So you can see it actually read 1 MB of data. And if you dig deep, if you click on this, you can even see the number of records and all those things. You can see, you can add these two things and it will be close to this number, 172,198. It is exactly same as 172,198 records. So after group by key, whenever we do the transformation, because we are not pre-aggregating to compute the intermediate results, it always the number of records that will be processed using map or flat map will be same as the number of input records if we do not filter anything. Now let me develop the same thing with reduceByKey. This is just to compare. Don't worry too much if you don't understand the program completely. Okay, so order items is already key value pair, which is order ID and order item subtotal. So I can just say order items dot reduce by key. It is similar to reduce function. Only difference is the same reduce function will be applied for each key. That's the only difference. And in this case, key is nothing but order ID. And we have to give the tuple a pair as the parameter. And we have to return whatever value type we are trying to process here. So this is of type float, okay, and we are trying to add. So let us create a first variable which is similar to aggregator or totaler, and then second one is element. Okay, so for each key, the elements are will be added to the total, and the total will be returned towards the end if we implement the logic total plus element. Okay, now it's done, and we can say dot. Let me use take of 10 dot for each println. Okay, so here you can see as part of the reduce by key itself, we are giving the aggregation logic. When we use group by key, we are just grouping the data. We are not doing anything. After grouping the data, again, we have to use map or flat map to perform further transformation. That is the difference between using group by key and reduce by key. Group by key typically follows map or flat map to further process the data, whereas reduce by key, we will aggregate the data as part of the API itself, whether it is reduce by key or aggregate by key. Now let me go back to this, click on the jobs, and let me click on this. You can see the entire job is executed now. So you can see there is a stage 10 and stage 11. If you go to stage 10, okay, you can see um, the shuffle right is only subset. It's not 87,942. It's only 29,388 because there are approximately 3 to 4 order items for each order. Okay, that's why we got like this. Similarly, the other task which process other half of the 172,000 records, the output is only 28,044. Only this data will be now given to the subsequent task, which will be executed in the subsequent stage as to perform the reduce by key that you can see here. And now it actually got so there is only one task to execute this, and the 1 minute. I think something is wrong here. Okay, I have used the take. I didn't use the collect. If I use collect, it will show different way. So let me use collect here rather than take. So collect and hit enter. And now if I go to the jobs, and if I click on this, okay, I think when it comes to reduce by key, it always okay. Let me wait for a moment. How is it? Is it okay now? Is it back? Not yet. Okay. I think this time it took. Yeah, now it is back. Okay. Now if you see this, the shuffle right of the earlier stage is 513 KB, and the shuffle read is 513 KB. And if you dig deep, you can see each of these tasks actually read 28,718 records, approximately 28,718 records. And if you compare with groupBykey, and if you try to add these two things, it is not 172,918. It is approximately 57,000. So that is the difference between groupBykey and reduceByKey. The difference is due to when you use reduceByKey, uh, some aggregation will happen on the mapper side as well. Okay. So there are few questions here. Let me take those things. So does the function defined in the reduce by key will be executed for all the values of the key? That's correct. It will be executed for all the values of the key, but some processing will happen on the map side, and some processing will be happening on the reduce side. So whatever logic you have mentioned to compute the intermediate results, sum of sums is always sum. So for example, let's say you have 10 numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so you can do sum of 1, 2 plus sum of 3, 4, 5, 6, 7 plus sum of 8, 9, 10. Whether you perform sum separately on subsets and add finally those intermediate values, it will return 55. Or even if you add all the numbers, so let me expand this a bit. Even if you run all the numbers, if you add all the numbers separately like this, the sum will be 55 only. Okay. So if you use groupBykey, you are doing this on the reduce side. Only one person is taking care of all the clubs or diamonds or spades or hearts. Hence, it has to process a huge number of data. Whereas when you use reduce by key, one mapper might be doing sum of 1, 2, other mapper might be doing sum of 3, 4, 5, 6, 7, and third guy might be doing 8, 9, 10. So the reducer will get 3, and then 25, and then 27. 3 plus 25 plus 27 is 55. So reducer will only add these three numbers. So if you use groupBykey, reducer have to process 10 records. If you use reduceByKey, reducer have to process only 3 records. Okay, so that is what is happening when we use the reduceByKey. And that will happen for each and every key we have in our data set to answer Bala's question. And then to let me check this Gopi's question. How does we implement the same aggregation if we need to run multiple fields in value part? Yeah, you have to apply the necessary transformation and you have to take care of it. For example, I want to get both the number of order items, the count of order items, as well as the revenue. Okay, so what I can do, first as part of the map function, the original map function, instead of just having order revenue itself, I can also have, let's say, order quantity. Order quantity is fourth field. Okay, and it is of type integer. Okay, now if I see order items dot first, you can see the revenue and order quantity as part of the tuple, which is value now. So now the value is of type tuple. So now to answer the Gopi's question, if I want to add the revenue together and the quantity, and then get the order quantity along with the revenue for each order, what I have to do is I just have to say order items dot reduce by key, and now total is of type tuple and also element is of type tuple. Okay. So what I'm supposed to do now, I have to say total dot underscore 1 because it's a tuple. Output also I want it as tuple only. Okay, so I have to put in bracket. Okay, and then plus total, sorry, element underscore 1, and then comma total dot underscore 2 plus element dot underscore 2. Okay, and then take off 10 dot for each println. So now you got both the revenue as well as the quantity. So you just have to deal with deal the structure as tuple. The only criteria which you need to keep in mind for reduceByKey is always your input value type in the pair and the output value type in the pair have to be same. Only then you will be able to use the reduceByKey. And also your combiner logic and reducer logic have to be same. We will see those details in a moment. Okay, so it shouldn't be difficult. It should be same. It should work. Yeah. So when it comes to Scala, it is a bit different to perform similar functionality. Yeah, definitely Spark APIs are a bit simple and hide some of the complexity. But if you get a good hang around the collections, I think it shouldn't be a big problem. So Amog is asking, so when we used when we should use groupBykey. So it's a bit early. We will see that in a moment. groupBykey should not be used for aggregations. Okay, except in some rare scenarios where uh, the number of records that comes as output after doing the aggregations is not much significantly different from the input dataset size. Then whether you use groupBykey or reduceByKey, the performance will not change much. So when it comes to aggregations, first priority should be reduce by key, then aggregate by key, then group by key. And for all non-aggregation functions, most of the times we use group by key. Group by key is very, very important transformation, and there is one separate topic on that itself. And when I cover that, your question will be answered without any doubts. For now, to answer your question, group by key should be given lower priority when it comes to aggregating the data. Okay, now let me, I hope you guys are clear on the difference about reduce by key and group by key. Primarily what combiner means. Combiner means as part of the shuffling, there will be some aggregation will be performed on the map side, map task side. Okay, that is what combiner means. So now let's go back and see these transformations in detail, syntax wise and all those things. I will give the example of reduce by key, and also I will give the example of aggregate by key. Before going into those details, let us recollect the differences. Reduce by key uses combiner, aggregate by key uses combiner, group by key does not use combiner. And then when it comes to syntax, reduce by key takes only one function as parameter. So if you look at the syntax of the reduce by key, this table is very, very important. I think it will not display here. So the way you can actually get the details is by going to Spark Programming Guide. Some of the functions, it does not autofill. I don't know the exact reason. So you can see reduce by key take two parameters, but only one is mandatory, and that is nothing but a function. Whereas aggregate by key actually take three parameters. One is for initialization purposes, and then one is for combiner logic, and one is for reducer logic. So aggregation will be used, aggregate by key will be used when your combiner logic and reducer logic are a bit different. So for example, sum of sums, your both combiner logic and the reducer logic is same. So combiner logic is this one, and reducer logic is adding these intermediate results. Here we are only adding elements one after the other. So whether you use combiner or not, the logic will not change much. It's the same. Combiner logic and reducer logic is same for sum, because sum of sums is always sum. Okay. Whereas average of average is not average. So you cannot use reduce by key for scenarios like average. Okay, in that case, we might have to use aggregate by key, where the combiner logic and reducer logic is a bit different. For that reason, it takes two parameters primarily. One is for combiner logic and other one is for reducer logic. In Spark terms, they call it as sequence op and combiner op. And also we should use we should perform initialization when it comes to using aggregate by key. I don't know why it is mandatory, but yeah, we have to initialize. Okay, so reduce by key and aggregate by key. Reduce by key have implicit combiner. Aggregate by key, we have to provide functionality for the combiner, so explicit combiner. Group by key, no combiner. And these things reiterate what I have explained. So I'm going to the next one. Yeah, when it comes to reduce by key, the input and output value type need to be same. Okay, so for example here, if the value is of type float, the final result is also of type float. I have to scroll up. But earlier when we actually developed the code, both input value type and output value type is float when I just got the revenue for each order. When I try to get the revenue as well as the quantity count, the input type and output type is float. Is tuple, which is having two elements. The first one is of type float and the second one is of type integer. So the data type of input value type and output value type have to match if you have to use reduce by key. And for aggregate by key, they can be different. They can be same and they can be different as well. So performance is high for aggregations, relatively slow for aggregations. when it comes to reduceByKey, AggregateByKey versus groupBykey. And reduceByKey and AggregateByKey can only be used for aggregations, such as sum, minimum, maximum, etc. for reduceByKey, average for AggregateByKey, and then for any other transformation, including aggregation, where the transformation is not resulting in reduction of the dataset size. In that case, using combiner can be a overhead. Hence, using groupBykey can be better in performance up to some level. So any Bykey transformation can be used for groupBykey theoretically, but we should give lower priority for aggregation type of functionalities using groupBykey. Now let us actually define a problem statement and try to come up with the code exploring the reduceByKey and AggregateByKey in detail. So for that, let us use order items as the dataset. It has 6 fields: order item ID, order ID, which is foreign key to orders, order item product ID, quantity, subtotal, and product price. And I have shown you the reduceByKey. First, I have used the map function to extract the order ID and subtotal, and then I have used the reduceByKey to get the revenue. Okay, so I will do that again just for the to put it in a proper perspective in one screen. So first I am creating a path variable. Then I'm using this functionality to get the key and value pairs of order ID and order item revenue. Then I'm just using reduceByKey to get the results. And I hope you are clear with reduceByKey syntax. It's same as reduce function. If you have used reduce function, it will be very easy to understand. Okay. To recollect, if you want to do it in a conventional way, what you will do? You will create a totaler, and then you will add element into it. So internally, Spark will generate the similar code for this function. Okay, that will be taken care by Spark and Scala compilers. Okay, so that is about reduceByKey. Now, if you want to use AggregateByKey and get, so using the same, sorry, let me recollect once again. So first I have created the path variable, and then I have created the order items. Okay, and whatever, sorry, not this one. And if you look at the output, order items dot takeoff 10 dot for each ln. And to answer Gopi's question earlier, I have used instead of using this, he asked me how to add 2 elements if the value is tuple. Okay, how to add individual elements within the tuple to get the final output. So earlier, what I have done, I have changed my map function to create the value as a tuple, which have both revenue as well as the quantity to get to the sum of the quantity. Now, if I don't want to change this order items, use this information itself and get the number of order items. Earlier, I got the sum of the quantity. Here, I just want to see how many items are there in each order. Okay. So for that purpose, my output is my output type is a tuple because I want to get both order items, order level revenue by adding all the order item subtotals for all the order items. So for example, for order ID 2, I have to add these 3 records and get the order level revenue. And also I want to return 3 because there are 3 elements in that order. There are 3 items in order. I want to get the count of order items. Okay, because I want to both revenue as well as the number of order items. It has to be tuple. Output value type have to be tuple, but input value type is only float. So we cannot use reduceByKey. If you evaluate against the table, we cannot use reduceByKey. We have to use AggregateByKey only. So how the AggregateByKey syntax will look like? So here I am creating a new variable called order items, AggregateByKey, okay, and then order items dot AggregateByKey is the function name, and it takes two parentheses like this, two circular brackets like this, and the first one has to be initializer. How you should initialize? Depending upon your output value. Whatever you are expecting as output value, you have to use that for the initialization purpose. What is our output value? Our output value is after a tuple, where the first element is revenue for each order, and the second element is number of orders. So I have to put it in circle brackets. And then because first one have to be double or float, I have to initialize using 0.0, and the second element can be 0, because I'm just trying to get the count. Now, as part of the second bracket, we have to at least provide two functionalities. One is the combiner logic, and the other one is the reducer logic. Okay, so both of them take tuples. So here, let me take call it as total and element. Okay. So now, first thing you need to understand the data type of these two. Element is this one. So the data type of this element as part of the combiner is this one, float. Okay. Whereas the data type of this totaler is not float. It is as per our initialization. How we have initialized it? We have initialized it as a tuple. So the data type of total is tuple, and the data type of element is float. Okay. So as part of the first element within the tuple, I want to add element to it. So the logic is, and output is also of type tuple. So I started bracket. Okay, and the logic is the first element I want to add the first element in the tuple. I want to add the revenue, and the second element I just want to add a hard-coded value 1, because I just want to get the count. So if I say 1 for this, 1 for this, and 1 for this, and if I try to add it to this total dot underscore 2, for order ID 2, it will be 3. Okay. Is it clear, or do you have any questions? This is very important to understand, and you should know the relationship between the initializer, the totaler within the combiner, and then the reducer. So reducer, we will say total and intermediate. Inter. Okay, now this intermediate is of type this one, which is nothing but tuple. Even total is tuple. Typically, the data types of these two will be same. Okay, it has to be same. It's not typically. The data type of these two has to be same, and in this case, they are nothing but tuple. Okay. So now what we are trying to do, again for the total, we are trying to add the first element. The first element of inter has to be added to first element of total. Second element of inter has to be added to second element of total. As the output is need to be tuple, I have provided circular brackets here, and then I am saying total dot underscore 1 plus inter dot underscore 1, and then total dot underscore 2 plus inter dot underscore 2. That will actually add both the tuples individually. The respective elements will be added to the totaler, and then close the circular bracket. I think it will fail. No, it did not fail. So now order items ABK is of type RDD, and each element in that RDD is of type tuple. The first element is order ID itself, which is the key, and the second element is the output, which is nothing but tuple. The first one is revenue for each order, and the second one is count for each order. Okay. Now you can say order items ABK dot take of 10 dot for each println. And you can see the result. To actually validate whatever you got here, you have to compare with that. Otherwise, we are not sure whether these are correct or not. So one way of doing it is you can actually do filter after processing is done, because the output is nothing but RDD. So you can use filter API and say rec dot underscore 1 equal to 2. Let's say we want to validate 2 and hit enter. Now you can see the count is 3, which is correct. And luckily our data is sorted, so we can easily compare. Otherwise, what you have to do is you have to do the filter on order items first, and then the result, and then you will be able to validate. We will do that also. So let us get order items dot filter rec implies rec dot underscore 1 equal to 2. Select for each println. You see there are only 3 records in that, and hence we got the count as 3. And then you can add this 199 and 250 is 449, and then 129 is approximately 130 is 579. Okay, and we got the 579.98. So the results are correct. This is how you should validate. It is very, very important to filter after the transformation is done and make sure you validated your data. Okay, that is about reduceByKey and AggregateByKey. Any questions here? You can actually go through this material which I have provided, and I have given example for minimum also. So using products as dataset, I try to get the minimum priced products by category using reduceByKey. Okay, so that try to go through it and understand it, and let me know if you have any questions if you fail to understand this. So what is the question you have with respect to AggregateByKey? Let's take it from there. You don't understand AggregateByKey at all, or you don't understand the syntax? If it is only syntax, I will go through the syntax. If you don't understand the functionality itself or the theory itself, I can go through the theory. Hello?
Yes. Yes, Durga.
You don't understand? Hello, can you hear me? Hello? I could not ever, when you spoke, I could not understand that. Can you repeat that? Hello? Okay. So I hope you understand the significance of combiner. Okay, thank you, Pramod. Okay, so here, first you need to focus on this aspect. Okay, there are certain things which can be computed intermediate results, and then those intermediate results can be added finally to get the final result. No, don't use the terms called mini reducer and all those things. That is not correct. Combiner is not mini reducer on map side. That is not correct. What you need to understand, if you really need to understand functionally, what you need to understand is you need to go through these formulas which I have highlighted here. Okay, so I have let's take the example of sum. Let's say you have 10 different elements. Okay, if you have 10 different elements, you can create as many mutually exclusive subsets as you want with those 10 elements, and you can add those mutually exclusive subsets, and then you can get the results, and you can finally add. So in this case, I got 3 mutually exclusive subsets. One is 1, 2, other one is 3, 4, 5, 6, 7, and third one is 8, 9, 10. Okay, I have added these 3 things separately. and uh, 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 and then I got the result. What will be the result? It will be 3, and then I think 27 for this, or 25 for this 5, and then 27. So 3 plus 25 plus 27 is 55. If you add like this separately, it will be 55. So this is called as sum of sums, or I think it is called as transitive. Transitive. I forgot the actual term. So it behaves transitively. So sum of sums is always sum. So as long as your ability to compute the intermediate results is same as the ability to compute the individual records, your combiner logic and reducer logic will be same. Then you use reduce by key. But there are scenarios where you cannot you cannot get the intermediate results and get the final result using those intermediate results. One classic example is average. So if you try to do average of average, you will get incorrect result. What you have to do? You have to get intermediate sum and intermediate number of records, and then you have to finally add those intermediate sums to get the final sum, and also add intermediate count of records to get the final count, and you have to divide the final sum and final count to get the average. So here, the reducer logic is to compute those to get the sum of intermediate results and also the sum of the number of records and get the final output. That is the reducer logic. Whereas your combiner logic is to just get the sum of some intermediate sum as well as intermediate count. Okay, you cannot compute the average and pass that average to the reducer. So here you need to understand the combiner logic and reducer logic are different. Example is average. Okay, when combiner logic and reducer logic are different, you have to go with aggregator. AggregateByKey API. You cannot use reduceByKey because you have to provide the functionality for combiner also. So in this case, the example I have taken, so you have this data where you have the order ID and the order item subtotal. Using this, I just want to compute the order revenue and order count. How to get the order revenue? I just have to add these 3. Okay, the final output is adding these 3 will give me order revenue. And also I just have to count these 3, which will give me the order count. Here, as my, so for, to determine whether, so in this case, my combiner logic and reducer logic cannot be same. Okay, because if I have to use reduce by key, I need to get some value to count to get the order item count also for each order. But here we only have order item subtotal. As we cannot use reduce, as the combiner logic and reducer logic are not same in this case, we have to use AggregateByKey. Okay, now I'm talking about the syntax. Okay, is it clear? Is the concept clear? If the concept is not clear, you have to watch the videos and you have to come back to me again. Now coming back to syntax, for some reason they expect us to initialize. Okay, and for that we have to use a separate circular bracket like this. It is called as currying in Scala, which I have not covered when I spoke about Scala. Except with AggregateByKey, you don't use this currying concept anywhere when it comes to Spark. That's why I didn't cover. Okay, so as part of this first circular bracket, you have to initialize. And as part of the second circular bracket, you have to provide combiner logic and you have to provide reducer logic. So these two are two different functions which I'm trying to apply as arguments. First, you should go ahead and look at the syntax. So AggregateByKey takes sequence op and combiner op. And what are these sequence op and combiner op? They are nothing but functions. They did not tell explicitly here. Anyway, I will cover that. So the sequence op and combiner op are nothing but functions. And they take, each of these actually take a pair as parameter, okay, and return some transformed aggregated result as value. For each key, irrespective of number of values we have, it will only return one value. Or subset of those values, like intermediate values in this case. Okay, so now don't worry about what is the return type for this. Primarily, you should focus on what should be the parameter for combiner function. The parameter is nothing but a pair, and it has total and element. And also for the reducer also, the parameter has to be pair. So this is one function which we are passing for sequence of. This is another function which we are passing for combiner of. Okay. Now comes relating all these things together. So whatever is your desired output. In my case, I want to get the revenue for each order and the count in the form of a tuple. Okay. As my output type is of type tuple, I am initializing to tuple here. That's why I put it in the circular brackets. And it takes, it requires two elements, one for revenue and one for count. Revenue is of type double or float. Hence, I have given 0.0 to initialize and then 0 for the count. Okay, so this is for initialization, which is required for aggregate by key. Typically, we will be initializing to zeros. Okay, and then comes the combiner logic. It has a pair as parameter. So there are two arguments which we need to pass to this function. One is named as total in this case, and the other one is named as element in this case. So first you need to understand the data type of these two. Okay. So the data type of total is as per your initializer. If you have initialized to tuple, your data type of total is also tuple. And again, this initialization happened depending upon our desired output. So everything is connected. Our desired output, initialized value, and the first parameter for sequence of everything is same. The data type is same. So total is tuple here. And then data type of element. So here we are trying to process this data to get the revenue, which is the driving factor for our function. On top of it, I also want to count these elements. So what I'm trying to do is I'm adding one for each record. So that's where this total dot underscore 2 plus 1 came. Anyway, first let us focus on this. So our first element is of type float, because I want to compute revenue as part of my first element within this total. So I say total dot underscore 1 plus element. Element is nothing but float, which is nothing but this value. So I'm trying to add order item subtotal of each and every record within the order to the first element in the tuple. So total dot underscore 1 plus element. Eventually, we'll have the intermediate revenue for each order. And then I'm adding 1 to the second element. Okay, total dot underscore 2 plus 1. We can hard code because we are just trying to get the count. Now comes the reducer logic. Okay, so when it comes to reducer logic, again it takes two parameters, and both the parameters are of type whatever value we have initialized earlier. It primarily the desired output for type drives this. So both the parameters which we are passing to reducer are of type whatever thing we want to get as output, which is nothing but tuple. Okay, so this is a tuple and this is a tuple, and initially it will be initialized to this value, and then in each iteration we are just adding the intermediate results. So here I named it as inter because this inter is nothing but this one, the intermediate results of this. Okay, and then total dot underscore 1 plus inter dot underscore 1 is used to add the intermediate results to the first element, and this one is to add the intermediate the second element of the intermediate results to the second element of total, and finally we will have the revenue and count. Okay, the only difference is here it will generate the intermediate values using which the final stuff will be computed. Okay, so that is about the syntax. If you still have questions, again you have to practice. This is a bit tough to understand. You need to practice. When you practice, it will be clear. So total dot underscore 1 and underscore 2, again, so think it as a reduce function. Okay. So what you are doing as part of the reduce function, you are having the totaler and you are having the individual elements. Initially, the totaler will be initialized to these values. Okay. And then intermediate results are nothing but your order item subtotal and 1 or some intermediate values. If you have hundreds of them, probably there could be 2 records which you will get here. Don't worry too much about it. Think this also as a simple reduce function. Okay. In this case, as part of the reduce function, we are dealing with tuples, and total is initialized to zeros in the beginning, and we are actually adding the elements. The first element within the tuple to the first element to the total, and the second element within the inter tuple is being added to the second element to the total, and that's how we are trying to add. So initially it will be 0.0 comma 0 for each and every key, and if you take the example of 2 for this one, the output will be after the processing is done is nothing but the total, which is 199 plus 250 plus 129, uh, which is I think it got disconnected, which is 579, and then 3. That is the output. Yeah, Shakti, you need to go ahead and practice a bit, and then you will understand. Okay, as long as you understand the concept, syntax, it shouldn't be a big deal. So depending upon the use case, you might have to first see whether you need to use AggregateByKey or not. Hardly will be using that. Probably out of 100 aggregations you perform, probably 5 or 6 times you might use AggregateByKey. Very rare you will be using it. Understanding the concept is important, and then depending upon the problem statement, you have to come up with the logic, and you have to use AggregateByKey and come up with combiner logic and reducer logic. So you have to go ahead and practice these things, and then probably it will be clear to you. That's what I cannot confirm what is the value of total dot underscore 1 as part of the first line. It could be anything. It could be any intermediate value. It depends upon how Spark execute, and every time it might change also. We cannot control that. So Amogi is asking, can we please also quickly go through filter again? So I have covered filter a bit in detail earlier. Now I'm only covering filter with respect to validating the results. Okay. Now you have, so we started with, let me log in again. Yeah, meanwhile I can explain. So we have created order items initially using this logic. Okay, so if you go through here, I have created order items, and the output is nothing but order ID for each record and subtotal. So to validate, typically the records will be random. There can be a number of records with order ID 2, and it can be random. As part of this sample data, it is ordered, but in traditional world, in real-time scenario, or in real world scenarios, all the orders will be scattered. All the order items for a given order will be scattered. It will not be in sorting order and grouped together. Okay. So to validate, first what you need to do is first you need to identify how to validate properly. In this case, I want to validate the reduceByKey or AggregateByKey functionality. Okay. So the input for these order items, input for AggregateByKey is nothing but a tuple. Okay. So I want to get all the tuples together. So Instead of running collect or take and then for each println, I have used filter to get only those order items that are related to order ID 2. Okay, so rec._1 gives this one, and I'm comparing that with 2 because I'm only interested in 2, so that I can validate for that one order ID whether the final output is correct or not. So here there are 3 elements because I have used collect, I haven't used take. As we got 3 elements, we can easily add these things. We can say that there are 3 records in this, and order revenue is $579.98. Once the aggregation is performed, if you want to validate whether the results are correct or not, on the final output also, you have to use this filter and try to get the appropriate record for that order ID, and then you can easily compare. If you don't understand filter at all, then you have to go back to row level transformations, and I have covered filter quite a bit in detail, and you have to explore it further. So we are trying to leverage the same thing today to just validate our results. It's not part of our actual functionality. Just to validate our results, we have used filter on top of RTD. Okay, as I have been mentioning, all the students, you have to spend at least 2 to 3 hours on regular basis to practice on these things. Otherwise, no matter how smart you are, you will lose the traction, and you will it will be very tough to understand a bit of advanced concepts which we'll be covering later. Okay, and also if you don't do so, Scala and Spark, if you are aiming for data engineer role by the time you come out of college, Scala and Spark is all 40% of the role. Most likely the programming language and the Spark can be up to 40% of your role. So you have to give that respect to these technologies, and you have to practice a lot to make sure you are comfortable with Scala and Spark. After that, Scoop and Hive, all those things are a bit easier. As long as if you know SQL, Hive will be easier. If you don't know SQL, Hive will be tough. So all these things are related. Okay, and if you understand these things properly, later when I discuss about SQL or other Hive, other technologies also as part of my future courses or workshops, you will not be able to connect well. So give enough respect to Scala and Spark, or Python and Spark, and practice a lot, and make sure these things are clear. If you do not practice, after a while you will lose the touch, and it will be very tough to keep up with so many technologies to stand out in this competition and get the data engineer type of roles in the companies once you come out of college. So you have to work hard, okay, and make sure you are able to digest these concepts. Okay, that being said, we are already at 10. So far what we have covered as part of transformations and actions is row level transformations, stuffing and combiner concept, and aggregations. Okay, don't worry too much if you do not able to digest AggregateByKey at this time. reduceByKey is pretty straightforward. groupBykey is a bit straightforward, but AggregateByKey, it might take a bit of practice to understand. But don't worry too much about it. Tomorrow we'll be starting with joins, and I will try to cover set operations also. Again, these are related. We have to use map function to create key value pairs to join the data set, and all those things. So unless you practice at least row level transformations, you need to understand filter, you need to understand the map, you need to understand flat map to understand these things in future, like joins, co-group, Cartesian, set operations like distinct, union, intersect, and also sorting and ranking, as well as groupBykey. Okay, so spend enough time on row level transformations and reduceByKey. You can give a little bit lesser priority to AggregateByKey, because out of 100 scenarios, AggregateByKey can be only 1 or 2, whereas others you will face quite often. Okay, so that being said, I will take a few questions here. Ashish is asking, to face interview as big data engineer, is it necessary to have good knowledge in Hadoop, MapReduce, or Spark and Scala knowledge is good enough? So for that, you need to understand the market condition. Okay, as of today, Spark is more important than MapReduce. If you talk about the past 1 year past, in the past, MapReduce is more important than Spark. As of today, Spark with Scala or Python is more important. Hadoop MapReduce. So for that, whether you should have knowledge in MapReduce or not, you can go to the dice.com and and search for and go for advanced search. Okay, and then let's search for data engineer. And yeah, so let's do what we get. Let's try to search and see what we'll get. So you see a lot of data engineer questions. Sometimes they might have big data, sometimes they might not have big data. Data engineer is more generic. So here, if you go to the job description, so here they are saying outstanding skills in SQL, Excel, ETL. That's what I'm covering. I'm covering ETL. Okay, and I'm creating a series of videos for SQL also, so you will be learn that also. Experience with working in Hadoop and distributed computing frameworks is a plus. So even though MapReduce is not covered, as part of Hadoop, you've already seen HDFS. And you see here, they're talking about distributed computing frameworks. So we are talking about Spark. You can confidently say that I'm not good in Hadoop MapReduce, but I have done enough work on Spark. So you are covered with the distributed computing framework. Okay, so this is how you should do the analysis of the job, and then you have to be prepared for the interview based upon the job description that is posted. And sometimes there will be a disconnect between the job description and the interviewer. That we cannot help much. But you should be prepared as per the job description. So in this case, it's primarily ETL, SQL, data visualization, etc. Outstanding data skills. So you need to understand these adjectives and make sure you go with that mindset. Okay, so let us see one more thing here. So Charles Schwab, it is another financial institution. Here they are talking about Teradata and all. So Scala and Spark might not matter much for this position. So if you want to narrow down the search a bit, you can actually say data engineer, and then with at least one of the words, Hadoop Spark. So you need to understand this advanced search. You need to use your analytical skills here itself. Okay, so let us see this clarity. Okay, it's a contracting portion, and they need everything on this earth, so you can ignore. Even will not apply for this. Okay, so more importantly, what you should focus is what you need to focus is on the actual companies. So in this case, none of the things are actual companies. Yeah, all state. Okay, screen got stuck. It will come back. Yeah. If you go through this, you can see key responsibilities. Key responsibilities is about what you will be performing on the job. Okay. But the more important part of job description you should focus is job qualifications. And again, there will be mandatory and desired. So mandatory, you should have the knowledge. Desired, it's nice to have. Okay. And if you see here, they are saying hands-on SQL and DB querying exposure preferred. Exposure to Hadoop ecosystem is a big plus. So you can claim you have exposure to Hadoop ecosystem, even though you don't actually get into the MapReduce part of it. Okay, they will not interview on Hadoop. They might be focusing on your SQL skills more, and you can see the desired experience is only 3 to 5 years. Okay, and most likely most of you guys are eligible for this as long as they are willing to sponsor H1 and they can enter an OPT. You can give a try for these kind of opportunities. Even if you don't have experience, you should write a cover letter, a nice cover letter, and send it across. Sometimes it will work, not always, but sometimes it will work. Now let us do one more search. I'm looking for companies like AWS, sorry, Amazon, etc. So let me say employment type as full time. See here, a lot of junk. I can say junk by seeing the client names itself. This is also putting on staffing. Yeah, I think this is a full-time person. And here you can see they are again focusing on Java, Oracle, and SQL. You can say I am good in Scala and apply for it as long as you are good in cloud computing and AWS, because this requires a bit of cloud computing and AWS. So these are the required skills. You can say Scala. Scala is the JVM programming language, and you can still apply. AWS, you need to have knowledge for this. That doesn't mean that you need to be a master in AWS. As long as you know how to set up EMR cluster, or what is RDS means, what is EC2 means, what is S3 means, that is more than enough. At least in one of the areas, you have to be very strong. Okay, but this emphasizes NoSQL. So by the time you come out of college, you have to focus on NoSQL also. At least one tool, either Cassandra or MongoDB, you should explore a bit in detail, so that it gives appropriate level of knowledge to get into the job market. And this is 8 years development experience. That's why expectations are a bit high. Okay, but earlier one, it's 3 to 5 years, hence expectations are up to that level only. Let me take one more example. Okay, this is Tech Systems. Tech Systems is a better company. Even though it's a vendor, it's a better vendor. Probably might not be eligible for most of these Tech Systems opportunities, and it is again 7+ years opportunity. And here they are asking for certification with one of the Hadoop distribution, prior experience with respect to big data, ETL tools, etc. So you need to do such kind of market research, and then you have to be up to date with the technologies, what the market is expecting by the time you come out of college. That is very, very important. And now I am primarily focusing on the current technologies. So these will not fade away very soon. Even if these fade away, as your foundation will be strong, you will be able to adapt to the new technologies very quickly. Okay, so that being said, so Gopi is saying, I faced some client interviews, they still ask about the concept of MapReduce, even though they are using Spark. Yeah, concept of MapReduce, you should know what is map, what is reduce, what is shuffling, and all those things. And Ashish is asking, are you planning any NoSQL DB training in future? Yeah, I am planning for Cassandra. I will try to give Cassandra as well as MongoDB. I have some content on MongoDB, but not much. And I will create a getting started with Cassandra, and I will create an actual course also. And as part of the course, I will all have both Cassandra and MongoDB. In one course, I will be covering 2 NoSQL databases, and I will be covering not only the core concepts of those databases, but also how to access data from those using this Spark or programming languages like Java, etc. So it will not be a very big course, probably approximately 8 hours for each of them. There will be 8-hour content. But I will give you an end-to-end overview about how to use the technology as part of the application development. It will take time though. So the main reason why I'm reaching out to students is especially those who are in the first semester. As these things take time, I will be able to cover all those areas by the time they come out of college. And also, by the time they come out of college, probably in 2019, I want to get into staffing also. So if my company got credibility and if I can get some direct clients, I will help in placements as well for all those guys who are connected with me from semester 1 as soon as they started on MS. Okay. So any other question here? Okay, then thank you very much, and we will catch up tomorrow. And those who are on YouTube, thank you very much for joining the session. And as I have mentioned to you earlier and many times in the past, please click on the like button. It means a lot to us. And also, if you want to share with your friends, you can actually click on share here and share with your friends on your social networking platforms. And if you need environment to practice, you just have to go for labs.itversity.com and enroll for the lab. If you need support, you can go for discuss.itversity.com and you can post your questions, and there are people who will be responding to your questions. There are some issues with respect to display. That is, sometimes it could be YouTube issue, it could be issue from my side. Most of the times, you just have to click on the settings and increase your quality of the streaming. Sometimes it might go to the auto mode. It might choose the lower resolution if you are in auto mode. So you need to understand the YouTube as well to make sure you get the best quality. Okay. That being said, Vasi is asking, could you please explain about combined-by-key too? No, I'm not going to cover. I am aware of it, but I don't want to cover because it is not officially documented. Combined-by-key is also a bit similar to AggregateByKey, and you don't need to worry too much about it. Okay. That being said, thank you very much. And if you want to give the feedback once the video is streamed, you can give the feedback in the comment section. Bye.